Hello, I'm Song Jiang. I'm Associate Professor in Computer Science Engineering Department of UT Arlington. I'm leading a system research group here. And in last semester actually, spring semester of 2019, we host 4 undergraduate students in our group for NSF REU program, Research Experience for Undergraduate Students. This is a program that we designed to prepare our students with better and insightful research experience. And also another purpose is through this program, we can outreach to underrepresented students to give them the opportunity to better prepare their career and future research development. And these 4 students, I select them in the fourth semester of 2018 in my class, which is computer organization and assembly language programming. I interviewed a number of students. I asked them to send their resumes and tell me their programming experience, capability, and their passion for research. These 4 students, they have been well performed in my class. I interview them, I select them, and I have high confidence on their success. And that is actually turns out to be true in this last semester. We have weekly meetings, work very hard, and we do programming, we do design, and we specifically working on a project to make our computer system more intelligent. We specifically, in this project, we try to make one important system component, which is prefetching and caching, more intelligent. We study the workload, understand how this workload can be learned by a model, and then make this model to guide prefetching and caching decisions. And in this project, the students actually have write thousands of lines of code, spend many hours, and write the program successfully, run the program, and produce the results. And in this presentation, each of them are going to share their experience and lessons have learned, and talk about a little bit more technical details. And now I would like to let each of these students to introduce themselves.
Hello, my name is Miracle Malaj, and I'm a senior, and I'm majoring in computer science.
Hey, my name is Luis Martinez, and I am currently a junior, and I am a software engineer.
My name is Michael Akitanya. I'm currently a sophomore, and I am a computer engineering major.
Hi, my name is Diego Bester. I am a junior in computer science at UT Arlington.
My name is Michael once again, and right here behind me is just the file format that we're inputting into our program. Initially, our project is based on prefetching, and prefetching is the act of speculating that data will be used later on throughout a process or a set of instruction sequence, for example, and retrieving that data from slower memory into faster memory, like a cache system within the CPU, so that we can speed up the process of our sequence or instruction that's being executed, or whatever data we're retrieving. So the initial design that we had was to, of course, design a set of input data that will run throughout the prefetching algorithm that we'll develop in order to simulate various scenarios. Of course, there's different instances where you can input or implement prefetching, such as there's difference like hardware prefetching or software prefetching. For example, hardware prefetching would be executing instructions within a CPU, or in software prefetching, such as in retrieving data from a storage system and stuff like that, or from web pages. But we were only really able to focus on simulating those kind of environments. And within instruction prefetching, for example, it would be way easier to obtain amount of hits rather than misses, because within instruction sequence, instructions are usually logical in how a computer executes its instructions. However, whenever prefetching data, such as web pages or storage data from within a storage memory or a hard drive, it's often nonlinear, and you can't really predict at times, or it's harder to predict at times how we're prefetching data. So we'll have to develop a more intelligent algorithm in order to predict what the user may want to prefetch earlier on. So yeah, so our input process to our first program that we developed was, of course, to generate a trace or a set of data to input into our prefetching program. And the way that we did it was we had every line symbolized like a process or a sequence that we may be inputting into the program, and each of the numbers just tell you in detail like what number to begin with, what number to end with, the way that we interleave a sequence or generate a sequence, the way that we grab from each of the sequences, the way we grab numbers from each of the sequences in order to interleave and generate a full trace or a sequence for the prefetching program. So that's what mostly the first program is for. So now my colleagues will talk about program 2, which is the actual prefetching program.
So I'm Luis. Real quick, I wanted to touch a bit on the program 2 of the Mythro prefetching. So the thing about this second program is that we also had to, in addition to figuring out the caching parts for our algorithm, we also had to include what was called a least recently used, or LRU, portion of this algorithm. So the way that we managed to make this work was that in order for this to synchronize with our algorithm, we had to get that. First we had to create a separate program that would take the output of the first one and feed it into the second one, so that we would be able to better manage the buffer that we create within the second program. So the reason why we would need this in the first place would be for like server applications, in instances where you'd have thousands of users on a server needing to access a certain database of sorts. So with this, and in addition to an LRU algorithm, we would be able to better micromanage the resources and everything that's data that's on the buffer, such that users would be able to get whatever it is that they needed straight from the buffer with next to no downtime, without having to touch the slower cache, having to touch disk memory. Now, I myself actually did not know much about this LRU algorithm, at least not until it was covered in my operating systems course. So with that kind of knowledge, I was able to apply that rather quickly. That within the same week, I was able to get a test program of my own to take buffer output from the program number 1 and micromanage the buffer in such a way that would keep only the more recent or the more frequently used items within that buffer.
Okay, this is our input file for program 1. Each line, as Michael said earlier, represents a process, and the first 2 numbers here represent the range of that process. The third number right here represents how many requests we're going to take from that process, and then the 1 here means we're going to take it sequentially, and 1 and 5 here, these 2 numbers here represents the interleaving pattern of how we're going to integrate all the processes together into one sequence, and then the 1 or 2 here represents whether we're going to do that, pick those numbers randomly or sequentially, and 1 means sequential, 2 means random. Okay, so this is a program for part 1. The class P represents a process, and each member of this class is an item inside of the process. So the sequence range, the pattern, distribution and such. And okay. Just what are you doing? Okay. This function here, the take function, is used to get the numbers out of each process. We're implementing the round robin style. So this function is called multiple times in my program. You are out of control. Like, okay, can you go up one more time? One more time. Okay.
Try squeezing in a little more.
Sorry. It's all right. All right. So here I'm reading from the file. I'm reading each line from the file and breaking apart each component in each sentence line in the file. Okay. And that's more of me reading from the file, creating the sequence, and storing it inside a vector of P objects, so a vector of processes, the process objects. All right, so down here is where I implement round robin. So here, this is used for just making sure that each sequence runs in order. So it always goes from the first sequence in the line to the last in order. So sequence 1, 2, 3, 1, 2, 3, 1, 2, 3. That's more. All right. So in here is where the distribution and of the sequence and interleaving pattern come into play. There are multiple lines, if statements that are used just to prevent some errors. And here, if the distribution of the process is 1, it's real bad. Sorry. Okay. How in depth do I need to go into like my code?
Minimal.
Okay, so here's where the interleaving pattern takes place. It varies depending on random or sequential distribution and random or sequential interleaving pattern. All right, and once all the processes are integrated into my vector sequences, which is an integer, it is stored depending on, whether the distribution was sequential, random, sequential, interleaving pattern, random interleaving pattern in a specific designated trace file. And here's where I stored in the file. And everything that will be stored in the file you can see on the terminal. Okay. Just run the program and then I show the terminal screen, I guess.
So go ahead and just say now we'll run the program or something.
Now we'll run the program and you can see what's saved inside the file on the terminal.
Nice.
So where we at?
Okay, so I guess, yeah. And then G++ already had it set up, so just go up a bit. Go up a little. I mean, just do it just to see, go up a little. Look.
Go up one directory?
No, press up the up arrow.
It'll show the past commands.
Alright, let's see.
Okay, so G++, yeah. Enter. And then,
Can we run A?
yeah.
Do you need it at any point?
No. All right, so that's what's stored into the trace file, in the trace file. All right, so now program 2, or part 2. It's the object 2/mod. Is this just one continuous take?
Mm-hmm.
Okay. The code, so I could do the code real quick.
Oh. Well, this is compiler.
Oh.
Let me use that one.
That's a new one. Okay, so this is where I implement the LRU that Luis was talking about earlier. If you'll go down, please. This is the LRU class, contains a buffer, and also the function to implement it. I got help, I'm doing research online and such, and all right, so limit here represents how many numbers or requests we see in the sequence in order for us to start prefetching for that sequence or that small. Okay. In order to start prefetching for that small amount or that small sequence inside of the big line of numbers. This represents the buffer size or the cache size, the limited size memory that we have. So we can only fit 5 integers in it at a time. All right, so we read in that long sequence I showed on the terminal into this program. All right, and here I implement the code necessary to check whether the sequence is long enough for us to start prefetching for it. All right. This is me just added comments to check, for misses and hits. And at the end, this one right here, now I'm going to run the program. Okay, so now we're going to run part 2 program, and that's what it is. It's not as good as I hope it would be with 6 misses. 94 misses and 6 hits out of 100, but hopefully I'll get it to better standards. And this program has helped me because before this, I didn't really know. I did know what the LRU was, but by doing this, it introduced me to that before I met it in my coursework. I ended up actually using the LRU in my software class. We had to implement a chat room, and for that we had to create a tab completion, and it's based off of how many words, the words that a user mostly types in. The most frequent words a user types in to the chat room, and we're supposed to tab complete for those words. And this is what I used to do it.
Hi, my name is Diego. I'm a junior with the Computer Science Department at UTA Arlington. And when I first joined the RU program, what was most surprising to me, as well as my teammates, is the creative freedoms we were given with Dr. Jiang throughout the research experience this semester. With our courses, we are so used to given the exact blueprints of what we are expected to meet. With Dr. Jiang, we would always ask at the beginning, how should I solve this? What method should I use? And we would always be surprised to hear him say, whatever you want, experiment, find what works best. And I think that has really helped me, as well as my teammates, really open our minds on how to find creative solutions, not only with this research, but in our normal classes and our other projects. And I really appreciate the opportunity that Dr. Jiang has given us. So close. And I really appreciate the opportunity that Dr. Jiang has given me and the RU program has given me. And I really hope to come back for the fall semester.